All right, we're going to talk about impulse and momentum. Impulse is when you apply a force to something over a period of time which causes a change in momentum. We have an equation which some would call the impulse momentum theorem that says that the force times the time, which, by the way, this entire thing here is called the impulse, equals the change in momentum. Now, using this formula is pretty straightforward. If you look at it again, most of the time we're not going to be changing the mass of something by applying an impulse to it. We're going to be changing its speed. So if I take a golf club and swing it and hit a ball, I apply a force for a certain amount of time to the ball, I'm going to change the ball's speed, not its mass. If we have 3 of these 4 things, we can solve for the 4th. So let's just do a quick example problem and you can see what I'm talking about. We've got a car with a mass of 1,000 kilograms and it is moving at a speed of 20 meters per second. What I'd like to know about this car with the mass of 1,000 kilograms and a velocity of 20 meters per second is how much force would it take to stop it in 10 seconds. All you have to do is take this formula right up here and solve it for force. If I do that, I'm going to divide both sides by time and I'm going to get the mass times the change in speed over time. Put the mass in first, 1,000 kilograms, and the change in speed. Now, I'm starting at 20 meters per second and I'm going to go to 0. That means I'm going to lose 20 meters per second of speed. That's why it's negative. I'm going to divide that by 10 seconds. On top, I'm going to have 20,000. I'm going to divide it by 10, and I'm going to wind up with negative 2,000 newtons. Now, the negative just means that I'm pushing opposite the direction of the motion of the car, which makes sense. If you're going to stop it, you have to oppose the motion of the car. Now, I do want to point out something. If you look at this equation right here, you notice you've got the force equals the mass times the change in velocity over time. I could rewrite that as the force equals the mass times the change in velocity over time. It's the same thing. I'm just rewriting it a little differently. And you might remember that acceleration is defined as the change in velocity over time. So this becomes F equals ma. This impulse momentum theorem is just Newton's second law, but written in terms of momentum and time instead of combining the change in velocity and time into an acceleration like this.